Welcome to this session of Business Mathematics. My name is Ashish Jain. I'm an assistant professor at the Department of Computer Applications at the Bhopal School of Social Sciences. Our today's topic is proportions. This is a brief outline of this session. We will start with introduction of proportion, types of proportions, important rules of proportion. So let's begin. Just like ratios, proportions are also a means of comparison. Proportion is actually a comparison of two ratios or two fractions. Proportion is an equation of two ratios in which we represent the ratios that are equal. For example, here we have on one side 3 boxes, on the other side we have some triangles. We have 6 triangles. Now here in terms of boxes, 2 boxes are of blue color and 1 box is of yellow color. That means my ratio of yellow color box to all the boxes is 1:3. On the other side we have 2 triangles of yellow color as compared to 6 triangles total. That means the ratio is 2:6. Now if we compare the ratios on both the sides, we have 1/3 is equal to 2/6, as we can represent ratios in terms of fractions. How it is equal to 2/6? That means if I divide it into a simple ratio, my answer is 1/3. Hence the ratio of both the sides is same. Here I can say that 1/3 is equal to 2/6. Now let us look at the difference between ratios and proportions. A ratio is a comparison of two quantities of same type, and proportion is a comparison of two ratios. Here in proportions we compare two ratios, not just normal quantities. The second point of difference is that in ratios all the quantities need to be of same kind, but in proportion, as we have seen in the above example, there is no need for same kind of values. Only first two quantities are to be of same type and the last two quantities need to be of the same type. Let us see the definition of proportion. When ratio of two like quantities is equal to the ratio of two other like quantities, then all the quantities are said to be in proportion and hence they are said to be proportional. Let us take an example. Let A and B are two quantities of the same kind and C and D are two quantities of the other kind. We can represent them as A upon B is equal to C upon D. Then we say that A, B, C and D all are in proportion. That is, they are proportional. They can be represented as A is to B. We have a proportional sign, that is double colons. C is to D. It is pronounced that A is to B as C is to D. This is how we represent proportions. Here the terms A and D are called extremes and the term B and C are called means. That means the outer terms A and D, they are called extremes and the inner terms are called means. We use a symbol, that is double colons, to represent proportionality. Also, the products of extremes is equal to the products of means. That is, A into D is equal to B into C. This is known as the rule of 3. It is a very important property in proportion and is oftenly used to solve the problems of proportions. In various problems involving proportions, we can use cross multiplication in terms of fractions to test whether two ratios are equal to form a proportion. Let us see types of proportions. The first type is direct proportion. If in a proportion the two quantities of different types are so related that if an increase or a decrease in one quantity or ratio results in increase or decrease in the another ratio. For example, we have A1 upon A2 is equal to B1 upon B2. If we increase or decrease one quantity, the other quantity also increases or decreases. For example, the relation between quantity and cost. If we have more quantity of a product, we have to pay more cost. So as one quantity is increasing, the other one also increases. Or if I decrease the quantity, the cost to be paid is also reduced. That means a decrease in one quantity results in decrease in the other. This type of proportion is called direct proportion. The second proportion is called indirect or inverse proportion. That means if in a proportion two quantities of different types are so related that an increase or decrease in one quantity results in decrease or increase in the another quantity, then we say that these quantities are in indirect proportion. That means A1 upon A2 is equal to B2 upon B1. Or take an example, we have quantities like number of workers and number of days. If we employ more people, we require less number of days to complete a work. That means if I increase one quantity, there is a decrease in the other. It's other way around also. If you work for more number of days, you require less number of people. That means if I increase one quantity, my other quantity is decreasing. This type of inverse relationship is called indirect or inverse proportion. The next proportion is simple proportion. It is a method of finding the fourth proportion from the three given quantities. Remember, for proportion, we should have four quantities A, B, C and D. It is also called rule of 3. We have already seen this. Here, D is called the fourth proportion. A is called the first proportion, B the second proportion, C the third proportion and D is called the fourth proportion. If we can represent proportion in terms of fractions, we have A upon B is equal to C upon D. Here the fourth proportion D can be found out as first having the cross multiplication, that is A into D is equal to B into C. Or from this I can say that the value of D is equal to B into C divided by A. The next type of proportion is compound proportion. It involves repeated use of simple proportions. A proportion that contains more than two ratios is called a compound proportion. Compound proportion is also known as mixed proportion, and for solving this we have to follow a rule which is based on rule of 3 and is known as double rule of 3. We represent compound proportion as like this. The main property to be compared is A1 is to A2. Now this ratio is compared to B1 is to B2, C1 is to C2, D1 is to D2 and so on. Here by the rule of double rule of 3 we have A1 into B2 into C2 into D2, that is the product of all extreme terms. It should be equal to product of all means term, that is A2 is to B1 is to C1 is to D1. For example, a relation between number of men, number of hours of work and number of days. Here we have three quantities. So it is an example of a compound proportion. We will see compound proportion in details later on in this session. The next type of proportion is mean proportion. If A, B and C are three quantities of the same kind, such that if we have a ratio A is to B is equal to B is to C, this B is common, then A, B, C are said to be in continued proportion. We can represent it as A upon B is equal to B upon C. Here B is called the mean proportion of A and C is called the third proportion. We can represent B as B square is equal to A into C by cross multiplication. Hence, mean proportion square is equal to the product of first term and the third term. Now we come to some important rules that we use for proportion. The first rule is invertendo. If A is to B is equal to C is to D is a given proportion, then we have B is to A is equal to D is to C. That means we just invert or change the use of B and A or the position of C and D. That is A upon B is equal to C upon D. It implies that B upon A is equal to D upon C. This is called invertendo. The next rule is alternando. If we have a proportion A is to B is equal to C is to D, then we have A is to C proportional to B is to D. Or I can represent it in fraction as A upon B is equal to C upon D. It implies that A upon C is equal to B upon D. Here we take the alternate terms, that is A, C, B and D. The third rule is componendo. It says that if we have a proportion A is to B is equal to C is to D, then we can have A plus B is to B is equal to C plus D is to D. In terms of fractions, we can write it as if we have A upon B is equal to C upon D, it is equal to A plus B upon B equal to C plus D upon D. This is componendo. The next rule is dividendo. Just like componendo, here we use subtraction. So we have a proportion A is to B is equal to C is to D, then we have A minus B is to B is equal to C minus D is to D. That is, in terms of fractions, we can write it as if we have A upon B is equal to C upon D, then A minus B upon B is equal to C minus D upon D. The next rule is componendo dividendo. It is a combination of both componendo as well as the dividendo rule, according to which if we have a proportion A is to B is equal to C is to D, then we can represent it as A plus B is to A minus B. it is equal to c plus d is to c minus d. That is, in terms of fractions, a upon b is equal to c upon d. It implies that a plus b upon a minus b is equal to c plus d upon c minus d. These rules are used to reduce the problems of proportions. Now let us look back what we have covered in this module. We have started with the concept of proportion. We have seen the types of proportions. We have seen various important rules of proportions. We have seen direct and indirect proportion. We have seen compound proportion. I hope this would have given you insight into this topic. Please do practice for a better understanding. Till then, happy learning. Thank you.